This podcast is on exponential growth and decay, and it's going to relate those to the concept of mathematical models. The general model for exponential growth is given here. It's A, which I have called A of t because A varies with t. When you change t, you get a different number of A. A is equal to A naught e to the kt. Now, when you supply the A naught and the K, you have what is called a mathematical model of growth. That is, the formula will tell you about the growth of the population. Let's take a look at the variables. A, or what I called A of t, is the amount present at time t. If it's population, it would be an amount of people. If it's radioactive decay, it would be the amount of some substance. It could be any kind of amount that is growing exponentially. A0 is the amount present initially, that is at time equals 0. This experiment starts at some time, that's called time equals 0. K is the rate of growth or decay. If K is positive, we call it a rate of growth. If K is negative, we call it a rate of decay or a rate of decline. And t is the time measured from time equals 0. So if A0 was an amount present in 2002 and I want to know the amount present in 2020, then I would say that t was 18 because that's 18 years from 2002 to 2020. So it is an elapsed time from time equals 0. Now remember that rates like K or interest rates have to have a time unit associated with it. And K and T must agree in their time units. So I made a little comment here. I say if T is in years, then K will be a rate of growth or decay per year. If K is a rate of growth monthly and you solve for T, then you're going to get T in months. So if you'd want T in years, you'll have to divide by 12. But K and T have to have the same time units for this to work. Okay, let's do some examples. Example 1, it says our starting time for this problem is in 2006. What I've given you is the Indian growth rate. That's the nation of India. It's a growth or decay rate, and it's given by A equals 1095.4 e to the 0.014 t. Now the 1095 is in millions of people. So over 1,000 million is a billion. So this would be 1,095,000,000 people. 1.095.4 times e to the 0.14 t. And the Russian growth rate model is A equals 142.9 e to the negative 0.004 t. Now these are mathematical models of the population. Let's see what questions are asked. Question A, what is the Indian growth or decay rate? Well, the Indian rate is a positive number. K is greater than 0. It's 0.014, so it's a growth rate. And we usually do growth rates or decay rates in percent. Now, the way you change a decimal to a percent is you move the decimal 2 places, and when you go 2%, it gets bigger. So we would say growth rate 1.4%. In the Russian case, the K is negative, so that's going to be a decay rate or a decline rate. The population of Russia is declining, and again, you'd move the decimal 2 places, so it would be negative 0.4%. Now, the next problem says, what will the Indian population be in 2020? Remember, the base year is 2016. So in 2020, 14 years will have gone by, so T will be 14. And this is a straight plug-in. I want to know the population, that's A, or A of T, and that's going to be 1095.4 e to the 0.014 t, but t is 14. Now you'll probably want to put that in a calculator. Hopefully you're using a graphing calculator. If you put that in a graphing calculator, you've got to remember to put a bracket around that exponent because there's more than one number in that exponent. Anytime an exponent has more than one number, be sure you bracket it. And you get 1095.4 e to the power open 0.014 times 14 close. Now when you put into that into the calculator and you press enter, you get 1332.6. So that says that in 2020 the population of India will be 1,332,000,000 people. Let's go on and try the next one. It says when will the Russian population be 135, and this is supposed to say million, so I'll just add it on here. When will the Russian population be 135 million? Now note that initially the Russian population is 142.9 million. And that's in the year 2006. So what we'd like to be able to do is we'd like to say find how many years it will take for A to become 135 million, and we're doing it in millions, so I just put 135, and the final answer will be in millions. Okay, this also is a plug-in, but this time we're plugging in for A, not T, so we write A equals A naught, 142.9, E to the K, we're given the K, negative 0.004, and times T is now what we're looking for. Now that makes this quite a bit different problem than the last one, because T is in the exponent, and if we're looking for T in the exponent, that makes this an exponential equation. So we have the two steps for solving an exponential equation. You isolate the exponential and take logs of both sides. So first we isolate the exponential. 135 over 142.9 equals, and here's the exponential, e to the negative 0.004t. So that's the isolate the exponential part. Next part is take logs of both sides. But what log? Well, the base is base e, so it makes sense to take the log base e. So I'll say ln, that means log base e, of 135 over 142.9 is equal to the ln of e to the negative 0.004t. Students like to leave this step out. I think it's very important that you put this step in. Now on the right side here, we've got an interesting thing. ln of e means the exponent of e that gives you e to the negative 0.004t. So that's just going to be negative 0.004t. Another way to think of it is ln and e to the x are inverses of each other. So e to the x changes negative 0.004t, but ln changes it back to negative 0.004t again. So it's kind of like the e and the ln crossed each other out. That's not really what's happening, but it's kind of that same effect. Okay, we divide both sides by negative 0.004. So on this side I get the log of 135 divided by 142.9. And that's going to be divided by negative 0.004 is equal to this divided by negative 0.004, so that's just equal to t. And you could put that into your calculator just like this and it would work. And if you wanted to bracket the denominator just to be safe, that would work also. Both those would work going into your calculator. And so you feed it in like that, and what comes out is t is equal to 14.22. Now 14.22, that's years. The question was when, and we were solving for t. Now remember the base year on our formula up here was 2006. So if it's going to take another 14 years for this to happen, then it's going to happen in 2020. So our answer is in 2020 the Russian population will be 135 million. Now in these problems we were given the math models. In the next problems that you do on the next podcast, it's going to be up to you to find the K. You find your own math models and then answer questions. So I'll see you in the next podcast.